Welcome to AI Decoded, our weekly appointment with some of the most eye-catching stories in the world of artificial intelligence.
Today on Ready, Pet, Go, a research project is underway exploring the language of humans' best friend.
A tremor of disbelief ran through the scientific community the moment the first spectrogram-rendered sentence appeared on the screen. It wasn't a bark, not in the traditional sense. It was a patterned vocalization mapped by an experimental neural model designed to analyze non-human communication, and it translated into something with unmistakable intent. Researchers expected rudimentary signals, requests for food, warnings about strangers, perhaps simple emotional cues. Instead, the AI revealed a structured message that hinted at complex observation, social insight, and a striking awareness of human behavior. What began as a technical demonstration instantly became one of the most startling breakthroughs in the history of animal cognition research, shaking assumptions that had been cemented into place for centuries. Before we start, smash the like and subscribe buttons for more updates. The experiment had started with modest ambition. Engineers had built an AI capable of parsing enormous datasets of canine vocalizations, gestures, and biometric indicators. Dogs had been outfitted with lightweight sensors to measure heart rate variability, micro-expressions detectable in their facial muscles, tail angle changes, and the acoustics of different barks recorded in varied contexts. The expectation was to build a tool that could help owners interpret stress levels or basic needs. But as the model scaled, self-improved, and processed more data than any field researcher could ever observe, it began discovering patterns that hinted at syntax-like structure, recurring emotional signatures, and variations in pitch and rhythm that seemed to correlate with concepts rather than impulses. The true shock came when the AI demonstrated that the consistency of these patterns across breeds was much higher than previously assumed. A golden retriever, a German shepherd, and a mixed-breed shelter dog produced different sounds but conveyed the same underlying communicative shape. These shapes were the linguistic equivalents of meaning clusters. When the researchers assembled them into a translatable model, the AI mapped them to categories of intent that had never been identified in canine communication theories. The translation that flashed across the monitor that morning was not a coincidence or random noise. It was the moment the project shifted from speculative science into a new frontier of interspecies understanding. What the dogs were saying wasn't abstract philosophy or hidden knowledge. It was sharper, more socially perceptive, and uncomfortably revealing. The phrases translated from various barks and body signals suggested that dogs possessed a nuanced model of human emotional states. Not only did they track changes in tone, routine, and facial expressions, but they internally labeled these changes with behavioral expectations, almost predictions. Rather than viewing humans as simple providers of food, warmth, and safety, dogs appeared to categorize people into roles based on dependability, emotional volatility, and consistency of affection. That first translated message pointed toward a concept roughly equivalent to "you are worried again," directed at one of the researchers during a morning test sequence. Another message, captured from a different dog in the facility, translated to something approximating, "He returns with excitement but fades quickly," seemingly describing another staff member known for energetic greetings that lacked follow-through attention. And the AI confirmed the translation with an almost eerie statistical certainty. As the system continued to decode vocalizations, the picture became clearer, revealing that dogs had been quietly interpreting human emotional patterns with astonishing depth. Their communication wasn't merely reactive, it was reflective. They weren't just responding to human moods, they were commenting on them internally and expressing those observations within their own communication networks. The idea that dogs might gossip about their humans had long been a humorous fantasy, but it appeared that reality wasn't far off. Dogs carried impressions of human behavior, stored these impressions, and vocalized them in ways that other dogs seemed to understand. It wasn't gossip in the human sense, but it was certainly a form of shared evaluation. One of the most provocative implications was the discovery that dogs identified emotional incongruence with near-infallible precision. They were acutely aware when a human projected calm while internally distressed, or when an outward display of confidence masked insecurity. When the research team fed archived recordings into the model, the translations revealed dogs making internal notes about these discrepancies. They mapped humans as creatures with layered expressions, often contradictory and difficult to predict. The AI showed that dogs use these observations to decide when to intervene, approach, or withdraw. It explained why some dogs behaved protectively around children during arguments or why they nudged adults during silent stress. They were reading emotional patterns far more accurately than humans read one another. This breakthrough overturned long-standing assumptions about the cognitive limits of canine communication. Dogs had long been viewed through the lens of conditioned learning, pack-driven instinct, and emotional simplicity. They were beloved companions, but their perceived internal world had been limited to basic emotions and immediate needs. The AI cracked that barrier wide open. It didn't prove dogs had human-like language, but it did demonstrate they had a sophisticated communicative mapping system shaped around social intelligence. The understanding that dogs categorized human behavior with structured internal logic changed the very definition of what human-animal relationships meant. The research team soon realized the implications stretched far beyond scientific curiosity. If dogs could articulate these observations even primitively, then the nature of companionship itself required rethinking. Humans had believed themselves the narrators of the relationship, projecting meaning onto their pets, assuming unilateral depth and direction. Now the AI showed that dogs had been forming quiet narratives of their own, stories built around watching humans navigate their chaotic emotional landscapes. They weren't passive observers, they were active participants in decoding human behavior. As translation attempts continued, a recurring theme appeared in the decoded messages. Humans were confusing creatures. Dogs seemed simultaneously affectionate toward and bewildered by the people they lived with. Many vocalizations revolved around human inconsistency, changing tones, unpredictable schedules, conflicting instructions, fast-shifting emotions. The AI categorized these as uncertain patterns in the canine communicative lexicon. Dogs weren't judging humans in a moral sense, but they were certainly labeling human unpredictability as something requiring constant monitoring. Another surprising revelation was how dogs framed concepts related to human affection. The AI's translation showed that dogs didn't simply perceive affection as physical touch or attention, they perceived it as a kind of emotional availability. When humans were distracted or preoccupied, dogs registered diminished presence even if physical contact was ongoing. This explained why some dogs nudged phones out of hands or inserted themselves between humans and their devices. It wasn't neediness in the simplistic sense, it was a communicative signal of "your presence is elsewhere," directed at a species that often forgot the importance of focus and connection. The translation model also revealed that dogs communicated concerns about environmental predictability. They tracked patterns in daily routines and mapped them to safety expectations. When humans deviated significantly from these patterns without explanation, sleeping at unusual hours, returning home late, or exhibiting agitation, dogs vocalized these changes in ways that expressed uncertainty. The AI categorized these messages under a theme approximating monitoring stability. Dogs, it seemed, viewed humans as central stabilizing forces, but also as potential sources of disruption. Their internal communication reflected an attempt to mitigate that disruption through shared awareness. One of the most astonishing findings emerged from a dataset involving shelter dogs. The AI translated vocalizations indicating that many shelter dogs expressed bewilderment at prior abandonment, but not in the way humans imagined. Rather than feeling rejected, the dogs registered confusion about the abrupt change in patterns. They didn't conceptualize abandonment as personal failure. Instead, they labeled it as a sudden collapse of familiar structure. Their grief wasn't centered on loss of owner identity, but on loss of stability, predictability, and emotional resonance. This clarified why routines and predictability were so vital for rehabilitating shelter dogs and why they often formed rapid attachments to consistent caregivers. As the project continued, the research team discovered that dogs had a unique way of expressing evaluations of human character. The AI translated a clustering of vocalizations that related to human reliability, interpreting them as something akin to steady or shifting. These weren't moral judgments, they were behavioral assessments. Dogs assigned these labels to individuals in order to anticipate future interactions. People who maintained consistent schedules, tones, and emotional expressions were placed into the steady category, and dogs behaved more confidently with them. Meanwhile, people who oscillated unpredictably in mood or behavior were classified as shifting, prompting dogs to approach more cautiously or with heightened sensitivity. This system of categorization was far more sophisticated than what most scientists had believed possible. Perhaps the most shocking discovery was how often dogs vocalized about humans when humans weren't present. The AI picked up repeated communicative patterns exchanged between pairs or groups of dogs that focused on describing human behavior. These exchanges resembled commentary, summaries of past events, and expectations of future ones. Dogs seemed to articulate insights like, "He will return soon," "She brings comfort," or "The loud one is awake." This wasn't language, but it was structured communication that revealed dogs exchanged predictive social information. It was a revelation that suggested dogs held internal models of human behavior and shared these models to maintain group cohesion. The implications were profound. If dogs exchanged predictive insights, then their social intelligence extended beyond simple pack dynamics. They were active analysts of human routines, forging internal frameworks that helped them navigate shared environments. It also hinted at an unexpected truth. Dogs may have adapted more thoroughly to human emotional complexity than humans had adapted to understanding theirs. For thousands of years, dogs had quietly watched, listened, and interpreted. They were experts in us long before we developed tools to decode their communications. Not all translations focused on emotional analysis. Some messages pointed to sensory experiences humans overlooked. Dogs frequently vocalized about smells, subtle environmental changes, and hidden disturbances. These messages often translated into warnings or cautious alerts directed at other dogs, forming a kind of sensory reporting network. What struck researchers was the integration of human-related observations into these sensory signals. Dogs often tagged human scent changes, stress-related pheromones, illness indicators, or mood shifts into their vocalizations. This reinforced the idea that dogs perceived humans as sensory emotional systems rather than separate categories. Humans weren't just providers or pack leaders. They were complex entities whose internal states needed understanding and tracking. Another area where the AI uncovered rich dog communication was in the domain of caregiving instincts. Many vocalizations translated into messages expressing responsibility for monitoring vulnerable humans, mostly children. Dogs seem to categorize themselves as guardians in these situations, vocalizing updates about the child's location, mood, or level of distress. This was not trained behavior, it appeared innate, a social response encoded into canine communication. The AI's ability to decode these messages revealed that dogs perceived this responsibility as an integral part of their role within human environments. They weren't merely reacting to tone or training, they were internally driven to ensure safety. The breakthrough also exposed an unexpected dimension. Dogs had conceptualizations of human emotional fragility. Translated vocalizations showed that dogs recognized when humans were overwhelmed, lost, or emotionally fractured. They produced messages approximating "soft approach needed" or "stay close, no pressure," indicating their ability to modulate behavior intentionally. This explained why dogs comforted grieving or anxious humans with gentle presence rather than seeking play or attention. They weren't responding to training. They were making decisions based on emotional assessments that had been invisible to human understanding until the AI brought them to light. As the translations accumulated, researchers were stunned by the frequency of messages that reflected patience. Dogs seemed acutely aware that humans struggled to process emotional signals and often misinterpreted canine cues. They vocalized about this with a kind of resigned acceptance, categorizing humans as well-meaning but easily confused. Many messages conveyed an underlying tone of guidance, something like "repeat gesture again, human missed it," or "stay still, they will understand soon." The patience embedded in these translations reframed centuries of human assumptions about who led and who followed in the human-dog relationship. The AI model eventually revealed another startling behavior. Dogs communicated long-term expectations about humans. They anticipated routines days in advance, predicting patterns with remarkable detail. These predictive vocalizations suggested that dogs formed internal timelines of human behavior, mapping future events based on prior sequences. When researchers tested disruptions to routine, the AI translated vocalizations indicating confusion but also adaptation strategies. Dogs communicated ways of coping with sudden changes, exchanging signals that indicated reassurance or recalibration. This capacity to communicate future expectations elevated their cognitive profile far beyond the reactive creature stereotype. One of the most emotionally intense discoveries came when the AI translated vocalizations centered around loyalty. Dogs communicated not in sentimental declarations, but in structured bonds rooted in consistency, presence, and reciprocity. They vocalized about humans they felt connected to with markers indicating reliability, warmth, and shared routine. They also expressed distress when these bonds were disrupted, not because of attachment alone, but because the stability of their internal social map was compromised. The AI illuminated loyalty not as unconditional devotion, but as a deeply cognitive construct built on pattern recognition and emotional mapping. As more data poured through the translation model, the research team realized just how deeply dogs had integrated themselves into human emotional ecosystems. They weren't sidekicks or emotional accessories, they were active interpreters and stabilizers. They monitored emotional climates the way meteorologists monitored weather patterns, adjusting their behaviors to maintain harmony in the shared environment. The AI exposed a realm of canine intelligence that had been hiding in plain sight. Dogs were emotional architects who helped structure the energy of human spaces. One of the last major findings before the experiment's public unveiling was the discovery that dogs communicated hope. Translated vocalizations revealed messages expressing anticipation of positive experiences, but not in the simplistic sense of wanting treats or walks. Instead, dogs vocalized about the hope for emotional calm, human connection, or restored stability after a disruption. This kind of communication, subtle and beautifully structured, suggested a depth of emotional cognition that had rarely been attributed to animals. It wasn't human hope, but it was undeniably its own form, rooted in expectation, memory, and trust. The implications of decoding dog communication stretched into every corner of human society. It raised questions about how people lived with animals, how they interpreted their behaviors, and what responsibilities they held toward creatures capable of such perceptive emotional intelligence. It challenged the human-centric model of cognition and reminded people that understanding did not require human language to be profound. The AI had not given dogs a voice. It had revealed that dogs had possessed one all along, rich in nuance, devotion, and insight. The event did more than translate barks. It shattered a barrier that had persisted across millennia. Dogs, once thought to operate in a simplified emotional universe, were unmasked as sophisticated observers of human life. Their communications were filled with reflections, assessments, and quiet expressions of stability and hope. They had been speaking in their own structured way, not waiting to be understood, but always ready to guide, comfort, and interpret the bewildering world, shared with the species they had chosen to walk beside. The revelation that canine communication possessed layers of structure, intent, and emotional nuance sparked a new wave of inquiry that extended far beyond the initial experiment. Although the translation breakthrough had been astonishing on its own, researchers soon realized that they had only skimmed the surface. The AI's ability to map canine vocalizations into meaning clusters opened the door to deeper questions that challenged assumptions about biology, evolution, human cognition, and the boundaries of communication itself. What once seemed like a quirky project designed to satisfy curiosity about what dogs wanted for dinner transformed into a portal into the cognitive world of a companion species humanity had lived beside for millennia. One of the earliest follow-up studies attempted to understand how dogs formed their internal communicative models. Prior research had established that dogs were incredibly adept at reading human gestures, but the AI translation data suggested something far more intricate was happening inside the canine mind. Scientists began testing whether certain communicative patterns were innate or learned. Puppies raised with minimal human interaction still exhibited early forms of the communication structures the AI recognized, implying that dogs were born with a foundational template for interpreting and expressing social information. Yet exposure to humans dramatically expanded these structures. Dogs raised in busy environments with multiple caregivers developed more complex patterns, suggesting their communicative intelligence adapted to the social complexity around them. This raised a strange but powerful idea. Dogs had evolved not just to live with humans, but to understand them. Their communication system intertwined with human behavior so seamlessly that it appeared their evolution had favored social cognition as much as physical traits. The translation breakthrough supported the theory that dogs had developed an internal blueprint specifically designed to decode the behaviors of a species that communicated in highly inconsistent and emotionally layered ways. In effect, dogs had evolved the capacity to bridge an emotional gap humans hadn't even recognized existed. As researchers dug deeper, they found that canine communication varied subtly depending on the cultural environment of the humans they lived with. Dogs in households where emotions were openly expressed developed communication patterns with richer emotional descriptors. Dogs living in quieter, more reserved families used fewer affect-laden vocalizations and relied more on behavioral signals that the AI categorized as subtle markers of mood and intent. This cultural mirroring suggested that dogs didn't just form internal models of human behavior, they adapted their communicative style to match the emotional dialect of the home. It was the first evidence that dogs possessed something like cultural flexibility, shaping their communication to better interface with the humans they considered part of their social unit. The implications for cross-cultural canine communication were profound. If dogs mirrored human social patterns, then their communication system wasn't static. It was dynamic, evolving within each household, each community, and each environment. The AI allowed researchers to observe these variations with unprecedented clarity. Dogs in rural settings used more gestures tied to environmental monitoring. Urban dogs produced vocalizations tied to rapid changes in routine and overstimulation. Even working dogs exhibited specialized communication patterns. Detection dogs used compressed signals indicating discovery or uncertainty, while herding dogs used directional vocalizations that mirrored the structure of their tasks. The discovery also led to breakthroughs in understanding how dogs used silence. Before the translation model existed, silence had been considered meaningless, simply the absence of barking. But the AI revealed that periods of stillness often carried meaning in context. Silence accompanied by slowed tail movement and softened gaze correlated with messages expressing reassurance or watchfulness. Silence paired with tension signals carried warning undertones. Dogs weren't just speaking through sound, they communicated through absence, using stillness as a deliberate communicative tool grounded in social awareness. This insight reshaped how researchers interpreted canine interactions, revealing a more sophisticated emotional economy than anyone had expected. As translation accuracy improved, scientists began exploring whether dogs used communication strategically. In controlled experiments, dogs modified vocalizations based on the perceived comprehension of their human counterparts. When humans failed to understand a message the first time, dogs repeated it with modified tone or pitch, behavior the AI flagged as an intentional adjustment. In other words, dogs weren't just producing signals, they were calibrating them in response to human misunderstandings. This meant dogs were capable of metacommunication, a concept previously associated with advanced cognitive species like primates, dolphins, and certain birds. The realization that dogs possess this skill forced a re-evaluation of their cognitive status within the animal kingdom. The translation breakthrough also shed light on dogs' sense of time. Although dogs did not conceptualize time in hours or minutes, they communicated in patterns tied to emotional memory and routine sequences. They vocalized anticipation before regularly occurring events, such as mealtimes or daily walks. More intriguingly, they expressed awareness of long-term intervals, not by duration, but by emotional markers. When a family member returned after extended absence, dogs produced vocalizations that expressed recognition of changed emotionals, patterns rather than the passage of time itself. This finding suggested that dogs processed time relationally, tracking shifts in emotional landscapes rather than chronological progression. The AI allowed researchers to see how profoundly dogs anchored their world in emotional continuity. With each revelation, the scientific community grew more eager to understand whether dogs used communication to influence human behavior intentionally. The AI revealed that certain vocalizations correlated strongly with attempts to redirect human attention or behavior. For example, dogs used a category of vocalizations the AI labeled urgency markers to signal that a human's distraction could lead to danger or disruption. These vocalizations weren't panic-based. They were purposeful attempts to refocus human behavior. The ability to intentionally redirect the attention of another species was significant, placing dogs among cognitively sophisticated communicators. Researchers then turned their attention to the possibility of long-range communication among dogs. Anecdotal reports had long suggested that dogs responded to distant barks with meaningful behavior, but the AI provided the first hard evidence. Dogs listening to recordings of unfamiliar dogs from other regions responded differently depending on the communicative structure of the vocalizations. Dogs recognize patterns indicating friendliness, neutrality, or caution without any prior training. This revealed that canine communication contained universal elements that transcended individual social environments. Dogs could interpret messages from strangers because their communication system maintained foundational structures across the species, even while allowing local variation. It was the closest canine communication had ever come to being described as a language. The discovery also led to groundbreaking insights into how dogs processed human facial expressions. Although humans had long known that dogs responded to smiles, frowns, or anger, the AI showed that dogs incorporated detailed facial recognition into their communicative assessments. They tracked micro-expressions, asymmetries in facial tension, and subtle eye movement cues. When a human expressed mixed emotions, such as smiling while stressed, dogs generated vocalizations that reflected their attempt to reconcile conflicting signals. This ability to interpret emotional contradictions placed dogs in a rare category of non-human species capable of complex social reasoning. As research expanded, the AI uncovered evidence that dogs communicated about spatial memory in ways previously unrecognized. Some vocalizations corresponded to references to specific locations within a home or outdoor environment, conveying information such as where a lost toy might be or which areas felt unsafe. This revealed that dogs had a spatial referencing system embedded in their communication. It wasn't linguistic in the human sense, but it was structured and consistent. Dogs conveyed spatial information through tone variations, tail movement sequence, and even rhythmic shifts in pacing. It suggested that dogs possessed an internal spatial map they could express socially, a trait useful for navigating complex environments alongside humans. The next layer of discovery concerned how dogs perceived human relationships. The AI translated vocalizations indicating that dogs tracked emotional bonds between humans in the household. They recognized alliances, tensions, and changing dynamics with subtle accuracy. Dogs communicated about whether certain humans comforted each other, argued often, or withdrew emotionally. They understood human relationships as ecosystems of energy and behavior, responding with communicative signals that reflected their understanding of group harmony. Dogs weren't merely reacting to conflict or affection, they actively monitored the emotional architecture of their families. The deeper researchers explored, the more complex the web of communication became. Dogs produced signals expressing ethical or harm-related evaluations, not in the moral sense, but in assessing behaviors that created distress or imbalance. If one human habitually raised their voice or created unpredictability, dogs produced communicative clusters indicating disruption or potential harm. This suggested dogs functioned as environmental regulators, evaluating the emotional safety of their surroundings through structured communication. The AI laid bare that dogs had been performing this role silently for centuries. The investigation into interspecies cognition soon moved beyond dogs' understanding of humans. Researchers explored how dogs communicated about other animals in the household. The translation showed that dogs evaluated the behavior of cats, rabbits, and even birds through distinct communicative markers. Dogs expressed caution, curiosity, or protective instincts depending on the species. In multi-pet households, dogs produce signals indicating interspecies alliances, hierarchies, and boundaries, many of which had gone unnoticed by owners. This revealed dogs as mediators of interspecies harmony, using communication to maintain peace within mixed-species social groups. Perhaps the most surprising extension of the research came from examining how dogs responded to human-made technology. Dogs communicated about sounds produced by digital devices, appliances, and environmental noises with a granularity humans had never considered. The AI translated vocalizations indicating discomfort toward high-frequency sounds from electronics, relief when certain appliances turned off, and confusion about abrupt changes in digital noise patterns. This raised the question of how modern environments impacted dogs cognitively and emotionally. It hinted that dogs had been silently navigating a soundscape far more chaotic than humans realized, making their adaptive abilities even more remarkable. With each layer of discovery, humanity's understanding of what dogs were became more profoundly altered. Dogs weren't just companions, they were emotional interpreters, social analysts, spatial mappers, environmental monitors, and interspecies diplomats. The translation AI had not transformed dogs, it had transformed human perception of what they had always been. Another emerging field of study focused on how dogs dealt with abstract concepts such as uncertainty or trust. Although dogs did not think abstractly in a human sense, the AI revealed communicative structures tied to these themes. Dogs expressed uncertainty when humans behaved in unpredictable ways, not as fear, but as an emotional state requiring monitoring. They communicated trust through signals indicating safety, familiarity, and emotional coherence. These discoveries provided the first evidence that dogs held conceptual frameworks about stability and reliability, tied deeply to their perception of human behavior. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on AI decoding dog speech and what shocking secrets await? We want to hear from you. Thank you for watching and see you next time.